Hi all, welcome to Geeks for Geeks. I am Utkarsh Kasarmani, your DSM mentor, and I am going to solve today's problem of the day. So let's start. BST with dead end. You are given a binary search tree containing unique positive integers greater than 0. So it is saying that you are given a BST. You know what is a BST? In BST there is a property that all the left subtree node, this is your left subtree, this is your right subtree. So the value of all the left subtree node will be less than this node, and the value of all the right subtree node will be greater than this node, and this condition hold for each and every node in this tree. So this is the condition for the BST. Your task is to determine whether the BST contains a dead end or not. Okay, so let's see what is a dead end. A dead end is a leaf node in the BST such that no new node can be inserted in the BST at or below this node while maintaining the BST property and the constraint all nodes values must be greater than 0. So it is saying that you have to check for the leaf node. What is the leaf node? Leaf node is a node that does not contain any child, means the left child is null and the right child is null. So it is saying that can you put some node here, or can you make a tree here, or can you make a tree here while maintaining the BST property. Okay, so how we can do it? If you will go by the brute force approach, then you need to come at each node uh, and find the maximum and minimum value it can hold by following the BST property. And if you will come to the leaf node, so you have to check that whether you can put any node on the left or any node on the right. Okay, so what you will do, let's suppose this is our first example: 8 5 9 2 7 1. Okay, so what I will do, uh, I will check at the leaf node that whether the left subtree or the right subtree can be formed or not, and if this is possible, so we will say that it's not a dead end, and if this is not possible, so we will say that it is a dead end. Okay, so how to do it? We know that what is the range of the value we can put here in a BST. So since it is a root node, and we know the minimum value can be 1 because it should be greater than 0. So the minimum value can be 1 and the maximum value can be infinity. So this, since it is already a BST, so the condition will always hold true for all the node. It will satisfy the BST property. Now if I will go in the right of it, so what the right node of this node will be, that the minimum value can be this 18 and the maximum value can be what the maximum value was here. So the maximum minimum value will change from this 1 to this 8. So the value can be from 8 to infinity. No, the value should be 8 plus 1. Why? Because this was our root, we have put this value here. So here the allowed values are 8 plus 1, means from 9 to infinity we can put any values here. Correct? Now we also see here that it's a leaf node because it does not contain any left or any right node. So if it does not contain any left or right node, so we can say that what is the possible number of values in this tree, or how many values can we put after this. If we will try to make a subtree, so what is the number of values we can put here? So what are the number of values we can put here? Similarly, we will do this infinity minus 9, which is somewhat equal to this infinity. It means we can put values here. Correct? We can put 2 here, not 2, from 9 to infinity. Now we can put not in the left subtree because we cannot put any value which is less than 9, but in the right subtree we can put 10, we can put 11, we can put 12 like this. So yes, this is not a dead end because here we have values. Okay, so from here what we will return, we will say that false, that this is not a dead end. And if at any place we will find out a dead end, we will return true. So we will have to take the OR. Now if I will come to this node, so this node is in the left of this 8. So it means what? The maximum value can be 8 here, correct? But 8 has already occurred, so the maximum value can be 7 here, but the minimum is 1. So 1 to 7, correct? This is not a leaf node, so further go. If I will come to this 7, so for this 7 the minimum value should be 5 plus 1. So the minimum value can be 6, the maximum value can be 7. This is also a leaf node. So I will again check what are the number of nodes we can put here. Okay, so if I will do this 7 minus 6, so it is equal to 1. I will put this 6 minus 7, 7 minus 6, which is equal to 1. It means that we can put one node here. We can put one node here. Also you can see that our node will lie between 6 to 7. So we can put 6 here. So it's also not a dead end. Correct? Because it tells us that how many number of nodes we can put here. So we can put 7 because the nodes allowed in this subtree was from, and this subtree was from 6 to 7. It means we can put 6 also in this subtree, we can put 7 also in this subtree. Total node we can put 2, but this is the node that we will not count because this is the node that is already following the BST property. That's why I was only subtracting that after removing this node. Means the total node in this subtree can be of size 2, but this is one node which already satisfies the property. That's why we are only doing maximize minus mini, not plus 1. So it is coming 1, means one further node after this can be made. Okay, so from here also we will return a false. It was 7 now. It was 7, and we will return a false here. Correct? So here false will go. Similarly, we will come at this node, and now at this node my minimum value will be still 1, but my maximum value will be 5 minus 1, 4. Now from here we can go to this left node. So this left node, for this left node I'm going since left, so it means my maximum value can be 2 minus 1, 1. So minimum will be same, but my maximum value is also 1. So this is also leaf node because no further child exists. So if I will calculate the difference here, so 1 minus 1 is 0. It means we cannot create any further node in this subtree. So if my maxi minus mini is equal to 0, we will return a true here. And if I will call for this right side, so what I will get? It says that my minimum value was 2 here, so the value can be from 3 to 4 here. But this is a null node, and if this node is null, so it means it cannot be a dead end. So we will return false here, and we will take the OR. So OR of this true or false will be true. Here true or false will be true, and here true or false will be true. So the answer for this is true. Okay, so if we will do it like this, so we are visiting each and every node of the tree. So our time complexity will be O of n, and we will call a recursion function. So our space complexity will be of O of h, height of the tree, because we are going till the height, then moving back, backtracking, then going. So So the maximum depth we can reach is till only the height of the tree. So let's code it. Bool solve. What I will have three things. First of all, root. I have a mini value and I have a maxi value. If my root is equal to null, it means we cannot get a dead end, and we will return a false here. Otherwise, if my root of left is equal to null, means the left there is no left child. Similarly, there is no right child, so root of right is also equal to null. So we will check that if my maxi minus mini is equal to 0, it means it is a dead end, else it is not a dead end. Otherwise we will calculate for left. So left is equal to solve of root of left. When we will go in the left, so what happened? When we are at any node and we are going at its left, so it means this was the maximum value. So all the values in the left subtree will be less than this. So my mini value will be same, but my maximum value will be root of data minus 1. And if I will calculate for the right, so bool of right, it will be root of data. Here for mini value, the minimum value was the root, so root of data plus 1, and the maximum value will still be same. So the maximum will still be same, and we will return here this left and right, or of both these two values, and here we will call this function. So return solve of root. My minimum value is 1 and my maximum value is infinity. Let's try to compile and run this solution. Submit this solution. Okay, so what's issue here? My root null, so false. If it is a root node, so we are calculating this maxi minus mini, and it is 0, so we are saying that it's a dead end. We are calculating for this left and for this right, so we are going for left, so our minimum value will not change, but our maximum value will change. So it's root of data minus 1. Similarly, here it will be right. Let's try to submit this solution now. Yeah, it has been submitted correctly. So this was all from my side. If you have any doubt, you can comment below, and thanks for watching the video. Have a good day. Bye.